Hello everybody. My name is Satyajit from Kokan Vinashkari Prakalpa Virodhi Samiti. As you know, there are a lot of scientific objections regarding designs EI of Jetapur atomic power plant. There are studies done by individual scientists. There is a lot of studies done by individuals regarding biodiversity of the region, oceanic life, and there are EPR technology and seismicity of the area. And we are always talking about unscientific clearance given by the Indian government to this Jetapur power plant. And there are no scientific study done by the government official or government's institution regarding this, including the NEERI, who has done the EI report on the Jetapur power plant. So we are other scientists like biodiversity experts and others are doing their research still going on. But I would like to introduce Dr. Roger Behan from the America, Colorado University, who has published research regarding seismicity of the Jetapur region in current science, and he has done a lot of study which has not done by the Indian Institute of Geography or any other institute. So he will present his research to you. And I would like to introduce Mr. Pradeep Indulkar, who is ex-PRC person, and he has done regarding EI objection. He has done very much scientific work there. So I will ask Mr. Indulkar to speak further.
I thank Greenpeace for calling us here. I welcome you all, and I would like to share some EIA facts with you about the Jetapur. The major problem with the EIA is we say that it is a very unscientific document of a very scientific project. Why it is unscientific? Because they have not done a proper study, the proper survey about the biodiversity as well as the ocean, the sea. The major problem with any nuclear power plant is related to sea, because all the nuclear power plants are coming somewhere nearby the sea, because they need lot of water for cooling. In present days, when we talk about the global warming and heat and climate change, we should take care of these heat generating units, because the nuclear power plant is the most heat generating power plant. If you compare with coal or any other thermal power plant like gas and oil. So the first victim is always ocean, and in this EIA, the first thing they have done is they have not done any study of the ocean. Whatever they have done, that is 20-year-old data. All the study, all the survey and modeling is based on 20-year-old data that was taken. That all the readings were taken somewhere in 1980. And the same readings they have used, and at many places they have said that we have assumed some theoretical data, some data from books, because that data was not available. Means they have not done that study, they have not taken the readings, and at many places also we found that they were not even done modeling like for thermodynamics and hydrodynamics of sea. Secondly, they have not done at all the 3D modeling of the sea, which was there in the contract. Third thing, At Jaitapur, I know many of you have visited Jaitapur. There are two major creeks of Maharashtra. One is Rajapur Creek and another is Vijaydur Creek, that Wagotan Creek. These two creeks are the major source of the water input in the sea, and there is a lot of current in and out through the creek. But because they were not having the readings of the creeks, they say that we assume that these creeks are closed. Now, after closing the creeks, how they can get the real dynamism of the sea? So that was our main objection on the about the ocean. Then secondly, the heat generating because of the hot water release in the sea. They say that our heat increment, that heat will be generated just the temperature will rise by 5 degrees. In America, a 1000 megawatt nuclear power plant generates 15-degree heat increase in the sea. So this is a 10,000 megawatt power plant, and this is the first time in the world where in one campus there will be 10,000 megawatt 6 nuclear reactors, and that nuclear reactors again, they are the biggest reactor in the world. So far nowhere it is tested. So how they can say that it will rise the temperature by only 5 degrees? The second thing, now we are more focusing about the seismicity of that area. Dr. Roger will talk in detail about that. But being a technician, I've worked there, and I know that, we have seen the Fukushima recently, and Fukushima was the first major problem because of the seismicity and because of that tsunami. That has come up, and we know all that because of the earthquake this can happen with nuclear power plant. But it was a major, it was a major event in seismicity and earthquake. But there were so many small earthquakes happen, as you know, all we have experienced in Mumbai also. So these small earthquakes are more dangerous than a bigger earthquake, because whatever happened in Fukushima, we have seen when such major incidents happens, immediately government and nuclear corporations, they take care and they evacuate people, they take all that medical facility and all those things. But these small earthquakes, they also give a major jerk to the plant, and because of these shakes, because if you see the nuclear power plant, it is a very complex piping, very complex this connecting pipes and electronic system, very delicate equipment we use there. Because of these small shakes, the leakages happens there at couplings, the joints, the walls, and these leakages go in the groundwater tables, and through that the whole area get contaminated. In the Tarapur, somewhere in 1967 or 70 somewhere, a major leakage happened, and our Prime Minister Indira Gandhi was going to close the Tarapur power plant. But somehow they managed to get through all these things. And such small events, they can easily, this nuclear lobby, they hide these things, and that is the slow poisoning for the surrounding area. The people, the animals who are staying in nearby area, this gives a slow poisoning, and that's a major cause, because of this the contamination happens, and then the health effect, like on the basically on the children, we find, because in Britain we don't have that type of culture here to make any scientific survey, but in Britain they have done some scientific survey, and they found that within 50-kilometer radius from the power plant, the leukemia and thyroid cases are increased in 5-year-old children, and that is because of this type of contamination. So even small shocks can make a big effect in the nearby area of the any nuclear power plant. And in the Fukushima, when the EIA people, this IAEA team went to Japan, and the major blame in their report was the Fukushima, Daiichi Nuclear Corporation of the Japan. They have not taken any care while selecting that site for Fukushima, because as per the IAEA's norms, they should study the history of seismicity up to prehistoric period. And there they have done the study just for 100 or 200 years. And here for Chaitapur, when we asked under RTA, they have given us only for last 20 years study or data, which they have considered. Actually, this should go up to prehistoric period or the maximum period. We say that at least 1,000 years. Now, Dr. Roger will talk in detail about that. Thank you very much.
So I've got some pictures I'd like to show you. So one of the surprising things is that although your written history is older than many parts of the world, it really only gets to describing the details of earthquakes about 200 years ago. And obviously you've had earthquakes going on for many, many thousands of years, as I will show in a minute. But this picture illustrates the true measure of the problem, which I think very few people understand. What we're trying to, let me just put this in context, my entire talk is about this problem. If you want to know what the future of a particular region is going to be in terms of earthquakes, you need to know, you need to make a couple of assumptions. And you start off by assuming that the last few hundred years of earthquakes is going to be about the same as the next few hundred years of earthquakes. And there are various things you can do. You can find all the faults that you know about. These are where earthquakes occur. You can find how long they are, how big they are, because that determines the maximum size of an earthquake. And then you can say, well, could these all go together? In other words, if you have 3 faults that are cracks in the ground and are more or less in the same direction, could they all go simultaneously? This gives you a measure of what we call the maximum possible earthquake, the maximum credible earthquake, M max. So those are 3 things one can do by thought processes and by measurements. And then you can go and dig up those faults, if you're lucky enough to find them, and you find out when they last slipped, or sometimes how frequently they slipped. Now, this kind of study is only possible if you can find faults on the Earth's surface. And many of the faults that have destroyed houses and structures in India are in fact buried faults. They don't appear on the surface. In fact, there's only one surface fault we know about in the whole of India, and that is associated with the Latur earthquake. So there are problems. If you can't find the earthquakes, if you can't find the faults on which the earthquakes occur, then you can't do the sort of statistical studies on how frequently they occur. If you don't have a history of earthquakes, you can't do statistical studies on their frequency into the future. So let me just having said that preamble, I'll just show you what we do know about the area, and you can judge for yourself. So this is all the earthquakes we know about. This is 8,000 accounts of earthquakes that people have either written down or have recorded in newspapers, and people like you writing about them, and more recently, of course, on TV things. But there it is. It goes back to 1800. You'll notice that this side of the graph has hundreds of earthquakes. It goes up to 500 earthquakes or so in this entire time period, 1600 to now. So you're looking at roughly 400 years, and you're looking at roughly 500 earthquakes. So the first thing to observe is that you have roughly one earthquake a year, maybe two. Okay. Then secondly, on the left-hand side of the graph is the number of people noticing that earthquake. And these are these sticks, and you can see around this level, 100 people noticed that earthquake, and they send in reports about it. So for the Koina earthquake, which is the one near Jaipur, there were lots and lots of accounts. Many people felt it. You go back 100 years, rather fewer people would feel the same size earthquake, because there were just fewer people, and fewer people telling other people about it. So why does this suddenly start going up in 1800? Well, it was the British kept writing letters to each other, and the pundits writing it down, essentially, all started in 1800. Why isn't there anything earlier? Because there is a strong tradition of writing. The answer is that most historians were not interested in writing it down. Okay, so how many earthquakes were we missing? You do the numbers. If you go back 1,000 years or 2,000 years, we're missing 2,000, 4,000 earthquakes. They happened, they just weren't written about. So that's our starting point. We have a very poor historical record. Now, this is an interesting graph for you. It shows the number of people that died from earthquakes in the last 1,000 years. The first thing to notice is that 85% of all earthquakes that cause people to die have occurred in this map. And you'll recognize the map starts in Spain, and it comes all the way to the Philippines and Japan on the other side. So it's a large chunk of area of real estate, but it's only 12% of the Earth's surface. So let me just say it, 85% of all people that die from earthquakes die from the collapse of buildings in 12% of the land area. You know, this is kind of strange until you look at, well, what geological reason is caused by. And the answer is that to the north of this area you have the Eurasian plate, which is a great big land mass, not moving anywhere. And to the south of this area everything is moving north. Like the African plate is moving towards Europe, and it's creating all the earthquakes that are occurring in the Mediterranean region. And then the Iranian plate, the Indian plate, and the Philippine plate, they're all moving northwards and crashing in the region in between. And now, why do people die from earthquakes? They die from buildings collapse. This is where people live. This is a land area. Many of the other earthquake zones in the world are underwater. Fishes don't die from earthquakes because they don't live in houses. Okay? So that sets the scene. Now, if you look across this graph at the bottom, this is the, if you like, a measure of the damage done by earthquakes. You'll notice there is no grey area in India. The grey area is everything prior to 1500 that we know about. Prior to 1800. Remember the picture we showed? That just showed. There is no history in India. And I think you'd have to be a nutcase to say there were no earthquakes. Obviously there were earthquakes. They just do not appear. Okay, let's look at India now. This sort of grey topographic shading shows where India is, it shows where Jaipur is, and it shows where all the earthquakes that we know about have occurred. These are written about in catalogues. There are several catalogues. Some of them have errors in. Some of them are instrumental and very good catalogues, like the one that seismometers are recording right now in Jaipur. It's a fantastically good record of earthquakes that are happening right now. But it's not going to tell us anything about tomorrow unless we make the assumption that things are not changing over periods of hundreds of years. So the first thing you see is that all these circles are occurring quite close to Jaitapur. So why is this? Why are there not lots of earthquakes down here, south of Chennai? Why are there not lots of earthquakes in Cape Comorin or to the north? Well, it turns out there is a physical reason for this, which I will try to explain in a second. Now, this graph is latitude. Cape Comorin is Kanyakumari is at the on the left, and the Himalaya would be over here somewhere. This great blodge of earthquakes is the Bhuj earthquakes that happened in Gujarat a few years ago. There was another earthquake there 200 years ago in 1819 that killed about 2,000 people. 20,000 people were killed in this batch. But this is a long way from Jaitapur. What you'll notice, though, is that at the latitude of Jaitapur, there's a great big cluster of earthquakes. There are lots and lots and lots of them. Okay. It means that you can't say the region is aseismic. You could say the region right off to the left there is aseismic. And you'd probably be right. But remember, this is earthquakes going back to actually 1600, but very few in 1600. Most of them occurring after 1800. This next graph is an explanation of what kind of shaking you should expect at Jaitapur from all those earthquakes. I'll explain it. What you can have is, you have it here is distance from Jaitapur. Jaitapur is at 0 on this graph, as bullseye. And all these earthquakes here in Bhuj have very little effect in Jaitapur, obviously. You don't even feel them here. But what it means is that if you have a large earthquake in Jaitapur, see that one right at the top there, 7.6, that actually resulted in shaking at Jaitapur with intensity 4. Intensity 4 means, okay, you would all say, oh gosh, an earthquake's just happened if you felt intensity 4. But it would be all over by the time you finish the sentence. Intensity 5, some of you might be feeling a little apprehensive. You certainly feel the shaking, things would rattle a bit. But it isn't until you get to intensity 8 that things start really falling down. Now, nuclear power plants have to worry about intensity 6 and 7 because there are so many pipes. If you shake the pipes, okay, you can break the joints. Now, I believe engineers can usually solve problems that they're told about. So if they know there's a certain intensity of shaking, I'm not too concerned. They will fix it. I believe engineers are reliable people. I'm sorry, I think you're a good guy. And I think most people do their best. If you know what to expect, you'll get it right. So the question is, what does this graph tell you? Well, it tells you if you had an earthquake of magnitude 7 and it was within 200 kilometers, you'll notice you're getting intensities of 7 or 8 at Jaitapur. So if we have to worry about, could we possibly have an earthquake of magnitude 7? Well, we haven't had one in the history of the place. The largest in Jaitapur is trivial. In fact, we know there haven't been any earthquakes at all there that you can feel. But this is not a good argument that they cannot occur. The reason is that many of the ports in the world have large earthquakes and they're completely silent for the next 200 years. If you go to the San Andreas port right now, you'll find the region that had the 1906 earthquake is the quietest seismic part of California. There are no earthquakes there at all. It's simply because it's locked, the strain is building up. Nothing is moving. So the interesting thing is that silence, seismic silence, does not mean you cannot have future earthquakes. So let's have a look at the big picture, which I promised to talk to you about, the physics of why you have so many earthquakes here. This plot is interesting because it shows every 4 kilometers square. So every 20 kilometers we've said, what is the biggest intensity of shaking that we felt in that 20 kilometer bit? Okay? in the entire history of Indian recorded earthquakes? Well, you'll notice that there are some red areas in the Bhuj region where you have intensity 9 and 10. That would not be a good place to put a nuclear power plant, because it's had 2 earthquakes in the last 200 years, and that sort of suggests we're going to have more. So coming down to the Jaipur region, you'll see it's sort of yellows and green intensities. These are intensity 6 and 7. And Jaipur is sufficiently close to that blotch that you've got to be nuts to say that you can't have intensity 6 and 7. Could you have intensity 8? Well, yes, if you had an earthquake right under the plant or nearby. And you would need to strengthen the plant considerably if that were the case. Now here's the physics of what's going on. Can I borrow your piece of paper? So India is being pushed against southern Tibet by plate tectonic motions. And what that does is just crumple up the plate, it buckles it. Okay? What it means is that top of the plate, the central India plateau near Jabalpur, for example, is in tension because you're bending it. It means the base of the plate is in compression because you're squeezing it. So it's easy for me to do with a piece of paper, but imagine doing it with a telephone book. Now imagine doing it with a lump of concrete 100 kilometers thick, because that's what we're talking about, India. If you bend India into that shape and it's 100 kilometers thick, the stresses are enormous. They are so big they can break the Indian plate, and that's what's happening. The Indian plate near Delhi has a series of cracks in it caused by this motion. The Indian plate a long way beneath Delhi has compression in it caused by the bending of the plate. You can sort of explain the earthquakes that have happened in recent time just by looking at this diagram. Here is the Himalaya, there's the Ganges. The Ganges is going down. It goes down to about 4 kilometers. So 4 kilometers is a long way down if you're bending this lump of concrete, which is what India can be thought of. And it shows the region near Latur is in compression at the top. It means you get earthquakes very close to the surface, and it's in tension at the bottom. You have rather small earthquakes at the base of the plate. Now the problem with this diagram is that you'll notice it's not a localized effect, it's an effect that depends on latitude. What it means is if you're anywhere at the latitude of Latur or Poina, you must expect earthquakes near the surface. You must also expect the Earth's crust to be under enormous compression caused by this collision, the collision of 2 continents, the continent of India with the continent of Asia. So this is the setting, and if you have no history of earthquakes, you can't use statistics. If you cannot see the faults, you can image them with seismic reflection stuff. If you cannot see them, you can't dig them up to find out when they slip. So the only recourse is to look at the physics. And if I look at the physics, I can say, if you had an earthquake magnitude 6.3 in Latur, you can have one under Jaipur. And nobody can prove me wrong, okay? But you can say, well, you could be wrong. I admit, you could be wrong. But let me just explain. When it comes to nuclear power plants, you don't want, I'm sorry, I made a mistake. You have to say, what is the maximum possible earthquake that could occur? And I don't know what it is. But from the little history we do know, we can have magnitude 6.5, no problem. I don't know whether I have another picture. Yes, I do. This is perhaps a bit too advanced for you guys, but here is India. Over there is the Himalaya, what says frontal thrust. This bulge is the region near to the north of us. And you'll see 2 plots that have been superimposed on this. That, first of all, the stress gets to an incredibly high level, theoretically, from that physical picture of what's going on that I just showed you. You see where it goes up and it says 2.2 thousand bars. That's the pressure, that's the stress. You can calculate. from theory. Notice that it coincides with both the recent release in energy. You have 10 to the 15 joules of energy released from earthquakes coinciding with that theoretical bulge. That's a confirmation that this theory is right. The red diagram shows the numbers of earthquakes, and the biggest lines occur in the Himalaya. We don't have to worry about them here. But you'll notice where we are in the Jaitapur region and the Koyna region, you have the largest numbers of earthquakes, which is the very first picture I showed you. So that's the end of my story. I am stating nothing more than the obvious. This is common sense. If you have this process going on in India, you can have earthquakes wherever you want because of the stresses involved. But what we know from the small amount of history we have, that they are occurring preferentially along this belt, which Jaitapur is sitting in. So I don't think this is a problem. We just tell the engineers, design your nuclear power plant for a magnitude 7 earthquake. You're not probably going to have anything bigger than that, although we could have a discussion about that later. And seismicity isn't an issue. If you can design for a magnitude 7 and the intensities involved, you're okay. Thanks. Any questions? Yes.
If you could put all this data into kind of a mathematical model, to kind of a predictive analysis, have you done it?
Yes, well, everybody likes to do this. Now, what are they trying to do? They're trying to take all the statistics and throw it into, as you say, a mathematical model to confuse us. Okay? They can make predictions of any sort you want because there are no data historically to confine their models. There are no geological data on the faults. There's supposed to have been a geological study done in the region, but I haven't been able to find it. This is an alarm signal. Why can't you find a piece of science that's supposed to be telling us about the geology of a specific region? Now, it could be that nobody's, bothered to look for it. It could be it doesn't exist, but it could be, and I think this is of great concern. It could be because if something was being found and they want to cover it up. Now, I don't favour any of those three possibilities. But if I were in the nuclear, if I wanted to build this plant, I would like that document to be available so that the possibility of us interpreting what they're doing is, incorrect. I don't think we should have a conspiracy argument when there might be a much simpler one. But it's up to them to prevent that. They can diffuse it by making sure the report is available. And if the report is inadequate, then one should be done. What we would like to know is what faults there are on the surface, in the subsurface, and in particular, why the Jaitapur region is a marine terrace. Some of you know the area well, perhaps. You know that it's a platform. It's a beautiful planed platform, 5 meters above sea level. Well, if you're a geologist like me, you want to know why. Why is that 5 meters above sea level? It could be that sea level was higher and planed it off. And that's a very innocuous explanation. It could also be caused by the flexing of India. That's not so innocuous. That's a confirmation of the physical model that I've just presented. And it could be even more sinister. It could be that the terrace that Jaitapur is sitting on is in fact there because a very large earthquake raised the surface some time ago. And you could, we're allowed to speculate because the geological data have not been made available to us. It could be that this earthquake happened 10,000 years ago. And it could be that that's a very good argument for saying, well, 10,000 years ago, forget about it. I would say if it happened 10,000 years ago, it could happen again, today. In fact, the longer it was ago, the more likely is it to happen now. Why? Why am I able to say such a silly thing? Look, the Latur earthquake was not a seismic hazard zone until the earthquake occurred. And now it is a seismic hazard zone. But the reason the earthquake occurred is that it released a huge amount of seismic stress that had been building up for many years, and that seismic stress is now gone. In other words, Latur is now a very safe place to live. It had its earthquake. The next place to have an earthquake is near it. What's near it? Well, I'm afraid there are lots of places, including Jaitapur. In other words, the hazard may have gone up in Jaitapur because of the earthquakes in Koyna and Latur that have occurred. And these are the kind of statistics that need to be examined. Any other question?
For your report that you have made, did you get the data from the Indian authorities? I'm sure you all the data that you wanted. Did you get it?
Well, I have no feature axe to grind. I study the seismicity of India in general, and Himalaya in particular, and those data are publicly available. What puzzles me is that there are no publicly available geological studies that are. I mean, if you went to the nuclear people, you guys should be given. Yeah, here's the geological study that's been done. You know, we paid for it. Here it is. You know, study it and come to the conclusions that we did. But that document is missing, and I have not asked specifically of any people here. It's just that if you're a scientist, you expect these data to be available. It's free knowledge. It's not available, and it's not secret. There's just an absence of data. That is very suspicious.
You say that if the design can sustain magnitude 7 or 8 plus, then possibly we should go ahead with the project.
Yeah, I mean, unlike the problems that we heard about just now, with water temperatures going up higher than expected, or unlike problems of storing nuclear waste, the engineering of a power plant is simply a matter of money. Okay, if you know you should design it for a certain size, you just put more money into it. Engineers are delighted to be able to construct strong buildings.
In the time in Japan, Fukushima, the latest earthquake occurred was around 9 mega Richter scale. Okay. In that time, earthquake of that magnitude had occurred. Okay, so whatever logic you are saying that in this time the earthquake of, say for example, 6 or 7 magnitude has not occurred, that doesn't mean that it won't occur in future.
Yeah.
Okay. Same thing will be applicable to Jaitapur. Only thing is that you are saying that upper limit will be of around 7.
Yeah. Okay, I'd like to clarify a couple of things. First of all, there is an example of a magnitude earthquake in Japan. It occurred 800 AD, I believe, and it did produce a huge tsunami, and it produced the deposits that have been now found and show that its amplitude had to be about the same. Okay. In Jaitapur, we know of only one large tsunami. Well, we know of two. One from the 1945 earthquake in the Makran coast, and one that occurred in 1524 when the Portuguese fleet was parked off Goa. And that, we don't know the source of that earthquake, and we don't really know its amplitude because it was recorded by the ships offshore. And they were being tossed around by these huge waves. We don't even know about the run-up. So, your point was really that I'm saying we're not going to have magnitude 9 there. And I think that's pretty certain. There's no big enough structure to have a 9. There is no known structure to have anything as big as a 6. But it could be in the subsurface that such things exist. And in particular, there could be something offshore that is, in fact, more significant and could have a magnitude 7. That's speculation on my part. We haven't done studies.
Second thing is that authorities, government authorities are saying, or scientists are saying that tsunami of the kind which happened in Japan, that tsunami of that magnitude, say 50 feet high, that won't be possible at Jetapur. Okay, and that is why Jetapur is safe, because it is at the elevation of 25 meters high. At present, and plateau is 25 meters high.
Okay.
So is it the correct assumption that tsunami of this magnitude, or say for example lesser magnitude, won't be able to come? Say for example tsunami of the height of say 7 meters or 8 meters instead of 35 meters. Will it not be possible? Can you rule out 100%?
No, of course not. Let me give you an example. Let's drop a large meteorite into the Arabian Sea. Why not? You know, this is the problem with nuclear power plants. You have to consider the absurd and the unlikely and say, well, could it happen? The answer is it could, but it could wipe out Mumbai first. It's very extreme. The idea of having a 7 meter tsunami having an impact on a 25 meter terrace is that no, it's unlikely to do any damage. Wait, there's a simple answer for you.
I was asking whether 7 meter high tsunami is possible in the Arabian Sea.
Yes. Yes, it could, from sources that we are not thinking of. You see, if you're a seismologist, you think, where are the earthquakes? Well, I showed you where the earthquakes are. They're in land, and they're all in since 1800. That's your source of information. But let me give you another look at this. The western coast of India has large sedimentary deposits from the Indus Delta that are fairly unstable. You could have a small earthquake triggering a submarine slide that would produce a large tsunami. Okay, is it likely? No, but it could happen. The problem with nuclear power plants, you have to consider the absurd. And after Fukushima, all bets are off. You really have to think very carefully what is the most unlikely event and say, could it happen? And if you can not say it cannot possibly happen, you might have to design for it.
Assuming that there's a 9 Richter scale.
No, not 9 Richter scale. Intensity 9 is. You could have a magnitude 6 right under the plant that would produce intensity 9, and that's a very high acceleration. You know, it's an acceleration approaching 1G.
What would be the ground acceleration at that site?
Okay, well, you see, if it's intensity 9, the acceleration could exceed 1G. Let me just tell you what 1G is. It's this. You leave the ground. Basically, the nuclear power plant is thrown into the air. Well, that can't happen because nuclear power plants are tied to the ground, but it's a very large acceleration, 1G. You know, it's not, if you drop your computer on the ground, it damages it. Things happen at intensity 9 that are difficult. No, you can damage a power plant with intensity, 0.3G, I think. 0.5G, half the acceleration of gravity.
And will that get also magnified to the fact that the ground there is laterite soil? So will that
No, the ground, as far as I know, the terrace is calcareous. It's a rock terrace, but I'm not sure. I haven't visited, so I don't know. A laterite plateau. Well, that's an aluminium oxide. It's really hard. It's almost like granite. So it's pretty good. Question over there?
Sir, there have been reports for the past 5 years that locals in and around Jaipur have been complaining of tremors,
Yes.
which happen at dawn. So do you have any teams out there, or have you been following up on that team? Are you any
No.
kind of a data? available?
Okay, yes, I heard about those reports. Those are just considered to be small earthquakes. They're picked up by the seismometers. They did not originate in the Jaipur region, but they are close. And what do they mean? I mean, we were saying, does this mean something is in the offing? Well, probably not. But, I mean, there are one of the things I keep pointing out is that you have to assume that the past is going to be the same as the future in terms of average numbers of earthquakes of a certain size. there is some evidence that we may have screwed that up unwittingly. I don't know whether I have the picture. No, I don't. What's happened in the last 30 years is that India's constructed a lot of reservoirs to store water. And this acts as a load on the Earth's surface. It pushes down on the Earth's surface if you store water. And it turns out the Godavari region has probably the largest concentration of these reservoirs. And this corresponds to the trough in this area near Latur. It could be that the weight of those reservoirs is in fact causing above average seismicity. In other words, the earthquakes of the last 2 centuries may be not representative. They may underestimate what the future is.
I'd like to add to that, there has been a report published by the state government, the Environment Department in 2008, that the Earth's crust in Ratnagiri is shifting in that region and cyclones are predicted in the next 20-30 years. So do you have any different?
No, I'm not talking about cyclones. I'm an earth person. And you know, I think studies that relate the earthquake process to physical changes like large loads, changes of pore pressure in the seismogenic zone can in fact point to a change in the seismic setting of India. But there's a lot of speculation that's obviously nonsense, and you know it is. Any other questions? Yes.
Have you studied the Gulf of Magan point?
Yes. Oh, well, it's a seismic zone that is converging at 18 millimeters a year, about the same as the Himalaya. It is different from the Himalaya in that it's much wider and there's a lot of fluids involved, mud volcanoes and things. It had a magnitude 8 earthquake in 1945. We know of no historical earthquakes prior to that. But we sort of think that that's just because nobody lives in the Kram. If you go there now, it's just a few fishermen. Inland, very few people live. So if you go back 1,000 years, you might find other earthquakes, but we don't know them. They can occur.
That's what in turn triggers tsunami.
What happened in 1945? There are two interpretations. One is that the tsunami that produced a big run-up in Karachi and also in Mumbai and in a few places like Goa, tsunami was recorded. There's a wave that gets trapped on the coast, it bounces off the coast all the way down to the south before it runs out of energy. And that's one explanation. In other words, the energy is selectively focused on the coastline. The other explanation is that the earthquake triggered a submarine slide, and the submarine slide produced the tsunami later. It was a sort of delayed effect. And that goes back to my suggestion that you could have a very large tsunami produced by a collapse of the submarine fan, that's what it's called, cone of sediments. That happens very irregularly. You know, you just pile up sediments. What might trigger the instability of that pile of sediments is the fact that in the last few hundred years we've changed agricultural practices. We've stripped down trees and things that used to trap water. So there's a lot more sediments on the coastline ready to be precipitated. Again, this is another example of how the past is not a good guide to the future. We may have destabilized things, making them more prone to disaster. There was a question somewhere over there. Okay, back.
From a seismic point of view, is it possible to make a nuclear power plant completely safe? Taking everything possible.
I'd like to say yes. We have an expert here. The fact is they're very complicated gadgets, and even quite simple gadgets can go wrong, and complicated gadgets tend to have more and more complications in them to try to stop them from going wrong. So the answer to your question is, yeah, it's almost impossible to design a human thing that will never go wrong. Look at the space shuttle, for example. We have examples of the tiniest elements, just a little bit of rubber in an O-ring causing a catastrophe. So such things can happen in house plants. I think they are quite safe, actually, compared to my bicycle. They're much safer than my bicycle or your car, but it doesn't mean they can't go wrong. So I think, in a way, the seismic story is kind of done. It's obvious. It's common sense. We don't know anything, so we can't tell you what's going to happen in the future. You have to expect the worst. I think there are much more serious planning issues that you heard about earlier that need a fix and haven't got one yet. The seismic fix is just throwing more money at it. Yeah.
Does it worry you that it's better not to be a plant but a nuclear park?
Yeah.
Explain, sorry.
The idea is to have almost 10,000 megawatt capacity.
Yes.
There are 6 reactors.
6 reactors.
Yeah. It's a park, yeah.
Well, we can see what happens in places like Jaipur if you put too many reactors together. You compound your problems. You can't even get at them, perhaps, if you have a problem hanging around. But that's, you're now asking questions that the seismologists shouldn't speculate on. Right?
Recently in the Ratnagiri district, a lot of cracks in the earth have been observed, 10 feet long and 4 kilometers. What was the reason?
Now, that is interesting to hear. I don't know. I haven't heard about those.
Many times photographs and even recent reports have appeared in the newspapers that in some of the villages near Ratnagiri district, some 30 kilometers from Letapet plant, there has been a earth or the small hills, they have been moved and there are a lot of small sort of gorge type of things developed for kilometers long and
Yeah, I'm hearing you, and I haven't seen these in person. I can tell you the generic explanations for such things. Sometimes they're caused by groundwater withdrawal. It seems to be unlikely here. Secondly, they're caused by hill slope creep. They're not, to my knowledge, caused by seismicity. Okay. But this is the sort of thing that would be in the geological report that we have not seen. Our article, we thought we would just write up. Professor Gar and myself would describe the seismic background just so that people know what it is. And we wanted to add a section on the known geologic hazard or the tectonic structure of the region. And so we tried to find a report describing it. We learned there was one, and when we tried to get a copy of it, we ran into, we either didn't try hard enough, we didn't persevere, or the report does not exist. I've heard it from a geologic colleague, a geologist in Hyderabad, who's also trying to get this report from the GSI, and the GSI say, well, they don't have any copies of it. I mean, this is crazy. With science, this is science. So we expect science to be completely free and transparent, and it's not.
Earlier, this Delta region was reported in the seismic zone 4, and now government is saying that it's now in seismic zone 3. So can you throw light on this?
Well, I think it's nonsense. These zones are complete nonsense because they're based. Let me explain. Okay, 20 years ago we didn't have any zonation, right? And then earthquakes start happening, so they get these big bullseyes of zonation. So the bullseye appears here. Next earthquake, bullseye here. Next earthquake, bullseye here. This is stupid. It's describing history. It's not describing the future. This idea of changing the zonation level is absurd. If we had more data, it would make sense. But to have an earthquake occur as the reason for changing something you're trying to predict in the future is obviously nonsense. The trouble is there's not enough common sense applied to this. You know, there's more common sense in this room than there are in many of the seismic stuff. Oh, actually, don't quote me on that. No, I didn't say it. But you know what I mean. Essentially, this is the problem. If you become a scientist, you think you have sort of license to kill, and you can throw away common sense. No, you've got to keep common sense right in the foreground. Hello.
Hi. What's your personal view on nuclear power?
This is a personal view on nuclear power.
What is it?
I have to be honest. I think it is important for the survival of humans, but there are some problems that should be solved as we gather the power. Let me give you an example. I was just talking earlier about this. The disposal of nuclear waste is a serious problem. You have to deal with that, and you have to deal with it honestly and upfront. And to say you'll fix it in the future is unacceptable. And so the storage of nuclear power, if everybody in a room was certain that nuclear spent waste was being dealt with satisfactorily, I think many of the objections to nuclear power would disappear. Okay, if in fact nuclear waste could be stored, that hasn't yet been solved. Although I think there is a solution.
And just to follow up on that, would you have a suggestion for an alternative place?
To store it. Yes, I think everybody in favour of nuclear power should take nuclear waste home and store it in their basement.
No, as in for locating the power plant.
An alternative place. Yeah, let's think. I really don't know. I mean, you do need to cool nuclear power plants, and the ocean is fabulous, far more safe. This is the problem. Whether it can be done safely is up to the engineers, and you can't put a nuclear power plant in the Rajasthan desert, for example, because you can't cool it. There's no way of cooling the cycle. Essentially, you produce heat, and you have to dissipate heat in order to keep the energy flowing, and that's done at the moment by heating up the rest of the earth, the rest of the ocean. So I mean, it's a crazy situation, actually. What one should do is, in the ideal world, just live with water power, rivers and wind, wave energy from the oceans, sunlight. If we could live with that, it would be a wonderful world. It really would. One wonders why can't we do that? Well, the objection is sometimes the sun doesn't shine, like every day, every night. There's no sun. The wind stops blowing, the waves stop splashing around. There's usually an objection of that sort. And hydropower is the only one where in fact you can guarantee electricity during the night and when the wind's not blowing. So there are other solutions, like how about reducing the number of people on the planet? we create our own problems.
You must have aware of the Wisdom Mountain project in US, the central repository for disposing of spent nuclear fuels from all over the
Right.
Why that project was abandoned? Because they had quoted some geological reasons for that.
Yeah, there are geological reasons, but the main reason it's being canned at the moment is political. That the president needs the vote from Utah, kind of thing. I think Utah's a good place to store nuclear waste. I mean, what is there going on in Utah except gambling? And if storing nuclear waste isn't gambling, I don't know what is. So the serious answer to your question is that people have to worry about the future of the nuclear repository for a million years. Okay. Well, what has happened to man in the last million years is it's ridiculous to think about. You know, we came out of caves less than a million years ago. So where is society going? That's one problem. The other thing is that over millions of years you do have major changes of the geological type, and in Utah they discovered there are earthquakes, large earthquakes, and there is even volcanism. And the concern for that is that if you have a repository, you have an eruption nearby, have you designed it so they survive it? The other thing is climate change. Utah is currently very dry. Supposing we've now changed the weather system so they get wet. That means the water table rises and floods. There are long-term geological problems that can be posed to which the solutions are expensive. Right now, a lot of nuclear waste is dumped in the oceans of the world, by the way, which is crazy. The dilution capability of the world's oceans for nuclear waste is in fact quite large, but you can get concentrations if you get leaks, and the concentrations tend to be in the stuff we eat, the fishies. It's, on the whole, a very silly thing and stupid, and we ought to know better.
Thank you, sir.
We'd like to thank Dr. Roger for his presentation. आणि आता ग्राउंड लेवलवरची न्यूज जैतापूर परिसरातल्या आंदोलनाचं काय चाललंय. ओके. There will be a massive jail bharo andolan on 24th, 25th and 26th this January. All Gram Panchayats are going to boycott Jhenda Vandan flag ceremony on 26th. There will when children are not going to school for 24, 25, 26, and on 15th of this 15th Sunday, 15th January, there will be a nuclear reactor. That the model of nuclear reactor will be Dapan in Sakrinate village, and for funding purpose, the Janit Seva Samiti Madam, who is superheading this Andolan from last 6 years, they are arranged 10 rupees per membership per month from the nearby villages only. So we are not getting any foreign funds. We are just doing Andolan from the villagers' pockets, 10 rupees per month per villager. Nearly 10,000 villagers may be participating. This starting just now. And we invite you for this 24-25 massive jail borough. And this Andolan is led by the locals only, not any parties. That misunderstanding is gone. That some parties are supporting this Andolan, but not leading this Andolan. This Andolan is led by only the locals. That's the misunderstanding I want to clarify over here.